Welcome to our presentation of the S10 Framework for ABAP Objects, an exciting new technology for implementing web applications for SAP systems. With our S10 Framework, you can create comprehensive, convenient, and performant web applications for the SAP system, both within Business Suite and S/4HANA. The applications are responsive, meaning that the content adjusts smoothly to the various screen sizes, including desktop, tablet, and smartphone. Integration with the SAP Fiori Launchpad is also supported, allowing you to expand standard Fiori applications to include additional tiles implemented as S10 applications. The main improvement over the SAP UI5 framework is that the new web applications are both faster and easier to use. Just try them out and convince yourself. Another advantage of the S10 framework is the ease with which apps can be developed. Anyone familiar with ABAP select statements, as well as calling function modules and methods, can begin with development immediately. Neither special tools nor a new development environment are needed. Everything takes place within the normal SAP transactions SE38, SE80, and SE24 in combination with a local HTML editor and your PC. As a result of the direct access between HTML and the ABAP OO world, all the advantages of the HANA database are available without having to define an OData service each time. The following provides an overview of our approach. The key principle of the S10 framework is to provide ABAP objects with a web user interface. Just as classic SAP screens and SAP GUI provide user interfaces for procedural ABAP module pools and function modules, the SAP framework provides a simple and direct web interface for the ABAP OO world. Each ABAP object can connect to the user via a dialog written in HTML. Let's first have a look at a demo app. The screen shows a simulated tablet in SAP Launchpad. The S10 framework can be used both to design the tiles and also implement the underlying application. This example is based on SAP sales and distribution data pertaining to customers, orders, conditions, and deliveries. Once the basic techniques have been established, they can be easily applied to similar tasks in maintenance or human resources. Later in the video, we will modify the demo app to illustrate the software development process. For demonstration purposes, we focus on the tablet display layout with occasional comparisons to the smartphone mode. Let's start with the sales orders. The tile My Customers displays all customers assigned to a particular sales representative. This could easily be 200 or 300 customers. By clicking on Orders, all orders of the representative's customers are listed. For starters, a maximum of 1,000 open orders are displayed. In this case, there are 559. If we change the selection to All Orders for the past 12 months, the maximum number of orders is attained. Should we want to display more than 1,000 orders, the maximum can be raised up to 100,000. Let's go with 4,000 today. Just over 1,000 orders have been loaded, and we can browse through the list. The list can be sorted by clicking on the header columns. By selecting individual customer names, only the orders of a specific customer are loaded. The list can also be selected to only include orders above a given value. For example, over 50,000 euros. That leaves only one order. Or above 5,000 euros. Or any other order value. With the S10 framework, it is possible to set filters for the entries within each column in the display table. For example, all customer references appear in sorted order. Note that some customer references appear twice. Selecting one such entry, we see a separate line for each order as well as the sum of net values. Clicking on the download symbol creates a CSV file with the currently selected entries. This file can then be processed further, for example using Excel. Let's remove all filters and click on a row with an order. This opens up a window with all the details pertaining to the order, including a list of the positions. Clicking on the position number opens a window with the details of the order position. At the top, we find the conditions, in this case, the price. Further down, we find the entire document flow, and we can see that in our example, all steps, including delivery and invoicing, have been completed. Let's now go back to the list. Oh, that was the wrong button. We ended up all the way back on the Fiori Launchpad, so we need to click on Orders again and navigate back to the list. Clicking on the order position, the details are displayed. The left arrow at the very top takes us back to the Launchpad, whereas the lower arrow takes us back to the list, which is where we are now. Let's click on an item or material number, in this case 72, the kid's bike, to see the item details. This screen displays the up-to-date conditions for the item. If we select different customers, we can see that in one case the price is 503 euros, whereas for Mary's Bike Shop the price is 433 euros because of a 12% customer discount. The chart below plots the monthly sales in the last 2 years for the item and is followed by an image of the product where available. Let's now go back one step and see that it is possible to modify the order directly in this screen. After pressing on Change, we go to the overview of the order items and change the order quantity. This works only if the SAP system still allows a change for the item. The order status must first be checked via the SAP interface. Let's add one more monitor and press Check, and we get the OK. Under Contact, let's choose the only option, Tom Kuhlman, and enter TC as your reference. After saving the order, let's add a new position. That will be the fourth item. Click on the field to search for items. Under Product Category, choose Cycles. And Article 63, Trekking Bike. The default quantity 1 is what we want, and save the order. The screen shows the updated information. Our contact is now Tom Kuhlman. The quantity for the monitor is now 2. And the fourth order item is the trekking bike. Clicking on the top position, the document flow has changed. Because of the additional monitor we ordered, the order is now not complete. Clicking within the order hides the details and brings us back to the list. Any number of detailed views can be open at once, making it easy to compare entries. Jumping back to the Fury Launchpad and clicking on the article tile, let's again select the product category, Cycle, and go to the article details for Kids Bike. Our goal is to add a new field to the item details view and thereby present today's first example of application development in the S10 framework. The delivery plant should be displayed alongside other items under distribution data. The first step is to make sure that delivery plant exists as a class attribute in the corresponding ABAP object and that it is read. Then, this attribute must be displayed in the HTML page. Looking first at the ABAP editor, we find the statements pertaining to local class definition. In the S10 framework, classes can either be defined locally in an ABAP program, as seen here, or created as a general purpose class via transaction SE24, the ABAP class builder. Programming is more flexible when classes are defined locally and only when needed. However, using Class Builder has its advantages when code building blocks can be used repeatedly, something we will show later in the video. When defining a class either locally or in Class Builder, it is important to specify S10/any as the superclass. This makes the functions of the S10 framework available, in particular the direct communication with the user via the web. We now want to add an additional attribute to the class db_mvke. At the bottom of the list, we add the internal name dwork for delivery plant. This name can be found in the SAP Data Dictionary or by using the F1 Help button in the corresponding transaction, for example, MM03. dwork is also given as the data dictionary reference, followed by a comment. The read routines are implemented here in such a way that all defined attributes are read from the database table MVKE for the respective article. That means we are finished on the ABAP level, and all we have to do is activate the program. Let's now turn our attention to the corresponding user interface. For this, we open an appropriate file in the HTML editor. I personally use Microsoft Visual Code, but any HTML editor will work. Looking through the file, we see the HTML code for outputting article attributes. For example, bonus and commission group. Let's copy a section of code, in this case for product hierarchy. Paste it below and replace prod H with dwork for delivering plant. For each attribute, we can either specify the field label directly, in other words, delivering plant, or employ a reference to the SAP data dictionary using the label statement as seen here. This approach is particularly useful when working in multiple languages. In the output statement, using @text displays the standard descriptive name, which is automatically read from the appropriate SAP text table. Without @text, only the short label or ID is displayed. Of course, it's possible to display both names. For now, let's focus on the delivering plant name and add the ID later. Now we save the HTML file. Close the ABAP editor and start the application separately for testing. In this case, we don't want to access the app via the SAP Launchpad, because then we would have to upload the file to the SAP MIME repository every time we make a change, which of course is impractical during software development. It's more convenient to program and run tests with local HTML files and to upload the file to the MIME repository from time to time, something you may be familiar with from GUI-XT development. Let's click through to the item details via Cycles, Kids Bike, and go to the distribution data. And now we see that the delivering plant is also displayed. In this case, the factory in Bonn, Werk Bonn. In order to also display the plant ID, we can switch back to the HTML editor, copy and paste the output statement, and remove the @text after dwork in one of the duplicate statements. After saving the file, we go back to the item details, switch out to a higher level to update the view, and go back to the Kids Bike article, where we see that the delivering plant information also includes the plant ID, in this case 1010. As you can see, by programming in the HTML file directly, the development cycle is extremely short, and it's easy to tweak details of the user interface and try out changes in the layout. For example, we can choose a different output color in HTML with the Style command. After saving, we go back to the item details, exit the application, and restart. And now the plant ID number is outputted in red. The output color can also be defined dynamically in the ABAP program. For example, if you want to draw attention to particular values under certain conditions. We could highlight the minimum order quantity for items with a minimum quantity greater than 1. While code that determines whether or not the information is highlighted belongs in the ABAP program, the code specifying what the highlighting looks like is found in the HTML page. Thus, there is a strict separation between application visualization and application logic, which means that once the application logic is in place, the layout can be modified with minimal risk. While JavaScript may occasionally be necessary, most coding can take place in HTML. It is even feasible for a programmer within the team to specialize specifically on layout programming. Now let's go back to the HTML editor and remove the red output text. Below, we find the code for AUMNG, the minimum order quantity. This field should be displayed in red when the value is greater than 1. Going back into the ABAP editor, in the class Material, and the method read, where article information is read from the database. In particular, from the database table MARA, which contains the material number, and the table MVKE, which contains the material number, sales organization, and distribution channel. We now want to place our logic for highlighting the minimum order quantity directly below the read statements. If AUMNG is greater than 1, we assign the CSS class red to the AUMNG attribute. CSS and HTML form a single unit, and the CSS class is used for consistent design of font, font size, color, etc. The CSS class is assigned using S10 add CSS to pass the attribute name AUMNG as well as the CSS class name. The CSS class name can be anything you like. Let's use red. And all this only takes place when the minimum order quantity is greater than 1. Let's now generate the ABAP program and go back to the HTML editor. In general, it is best to define CSS classes in a central CSS file that applies to all HTML files. This is useful because we usually want to highlight noteworthy information using the same font color or type throughout the entire application. However, for the purposes of this tutorial, we are going to define the CSS class locally with a style tag in which the CSS class red is given the font color red. As a result of this code, the minimum order quantity, AUMNG, should be displayed in red. Let's save the HTML file and go back to the application to test our code. Because we modified the ABAP program, we have to restart the application. click on Article, choose Cycles, select Kids Bike, and scroll down to Minimum Order Quantity, which is now displayed in red. However, the red 2 is not particularly eye-catching. Presumably, it would be better if the description and the title were also in red. These changes can be made quickly by going back into the ABAP program, copying the line with the S10 Add CSS twice, changing one of the attribute names to AUMNG at label to make the label red, and for the second attribute name, we need the variable name of the unit of measure, which we find in the HTML file Mara Mines. After generating the file, we restart the application and see that the red font truly stands out now. For completeness' sake, we should convince ourselves that the minimum order quantity is not highlighted in the item details view for other articles. And yes, that looks exactly as it should. To review what we've done thus far, we added the delivering plant to the view, calling upon the SAP Data Dictionary for the plant name and description. The attribute name provides the link between HTML and the attributes of the ABAP object. This works when the name specified using name equals in HTML is identical to the attribute name in the ABAP class. In addition to referencing value, label, and field description using the SAP Data Dictionary, column headers as well as drop-down lists can be called upon and are great time savers during software development. Let's have a look at several more features of the demo application and go through some more software development steps. From the item detail view, we can jump back into the list of articles and choose a different display layout by selecting the smartphone option within the Chrome simulation. In the smaller smartphone layout, the table is displayed with fewer columns. Switching to landscape orientation, additional columns showing price and unit are added. The functions are the same as in the previous layout. Clicking on an article brings us to the item details view, where under distribution data, we see the changes we made earlier, involving the delivery plant and the minimum order quantity. It may take a little getting used to the smaller format, but all the functions are available and the app is still easy to use. This figure looks a bit odd. The reason is that in our example, the sales price is significantly lower than the purchase price. As a result, the calculated monthly turnover is negative. Clearly, this is something that should be avoided. Staying in the smartphone layout, let's have a look at the Customer tab. This view summarizes the information pertaining to a particular customer, including the next appointment and general customer information. Clicking on Contact Person, we can choose the contact. In this case, there is only one. See the contact details, as well as the dates and the subjects of all previous interactions. Clicking on Open brings us to the Edit Appointment screen, in which appointment details and reports can be entered or uploaded. This, of course, also works in landscape orientation. Nonetheless, the iPad format is clearly more convenient for the appointment view and also for the customer information, including partners and relationships, as well as for the Map tab on the far right, which displays the customer location in a separate tab with Google Maps with all its standard functions, including the ability to zoom in. From any customer view, you can easily call up the information for a different customer. Now we are in Montreal. Oh, that didn't work. Presumably the address is invalid, which results in Google showing us a world map. This customer drop-down list contains the customers assigned to a particular sales representative. We can also press the overlapping squares button to conduct a global customer search under Customer Selection. Search parameters include the country, city, and customer or contact name. In the list of companies for Switzerland, we can then scan for a particular customer number or contact name, and then select a customer. For a given customer, the tab in the surrounding area lists all customers in the vicinity. This is useful for planning your sales appointments within a region. The distance to the current customer can be varied using the slide bar, and the matching customers are read from the HANA database and displayed. Let's now go back and pick the Sales tab from the main menu. This brings us to an overview of the sales for the selected customer. In addition to multiple diagrams, a table is displayed at the bottom with sales volumes for articles at 2 hierarchical levels. The diagrams are generated using JavaScript freeware. The values are provided using ABAP, after which the diagrams are generated using HTML and JavaScript. The diagrams are interactive. For example, particular years can be selected or deselected. Here again, it is possible to change the customer while staying within the sales view. The diagrams and the table respond dynamically. Having explored the existing functions of the app, let's now turn our attention to programming several modifications. In the customer view, we not only want to see the address of the current customer, but we also want to be able to edit the address. That means we need to add a push button on the right of the screen, which will take us into a dialog box for address change. The key is that we do not want to program the dialog box within our application directly. Rather, we want to use a general ABAP class from the SE24 class library that offers this functionality and even has its own user dialog. The goal is for the dialog box of the address change class to be displayed within our user interface, allowing us to continue on exactly as before once the user has finished editing the address. For orientation, let's pull up the diagram from the beginning of the video. We currently find ourselves in the realm of ABAP objects, for example, for sales order, customer, and article. The ABAP class library has another object represented by this dark orange hexagon, which provides a user dialog for address change. We call the address change method of this object using a standard method call, and the called object now establishes a dialog with the user via its own HTML page, all within the context of our application. While the address change dialog is active, the dark orange object has control and can send messages to the user and also call other dialogs if needed. When the user finishes the address change, the HTML screen is closed and our application continues, for example, with the green object. This illustrates an important feature of the S10 framework, namely its modular approach, which allows us to outsource functions, including user dialogs, in reusable classes. Some of you may be familiar with this approach from working with function modules in SAP GUI that could process their own DynPros or screens. With the S10 framework, this is now also possible for ABAP objects and web applications. We now want to have a look at these reusable classes under S10 Customer in the SE24 ABAP class library. Opening up the parameters of the method address change, we see only one parameter, namely KUNNR, which stands for customer number. And that's all we need for the call to work. There are a number of attributes that will appear in the HTML page of the user dialog of the method address change, but we don't need to delve into these details to achieve our goal. The following summarizes the main steps in the process. Via the command S10 dialog, the object initiates a user dialog defined by the HTML page address change dialog.html. Here, as we saw for articles, class attributes are displayed and can be changed. For example, the attribute building with the SAP label building code, with the corresponding user interface shown on the right. This was just to review the main steps in the process, but to use this approach we only need to know the name of the method and which parameters are relevant. In this case, the customer number. The first step of implementation is creating the push button to call the address change method. Let's open the corresponding page in the HTML editor named customer main.html. Using name 1, name 2, etc., the company name and address are displayed. Associated with this information, we want to place a push button so that the user can quickly change the address. We do this with the HTML tag button and the CSS class button. And finally, the text change customer address. That should be enough to have the button appear. However, at this point it has no function on the ABAP level. As was the case for attributes, the connection between the levels has to be made using the name equals statement. In this case, referring to the ABAP change address method. That should call the method change address in the active ABAP object when the user presses the push button. Let's test our code by first saving the HTML page, going out of and coming back into Customer View to refresh the display. I switched the browser cache off earlier, and yes, the push button for address change is displayed, but it is not in the correct position. We want it on the right-hand side above the edit buttons. To fix that, we jump back into the HTML file and add the statement style equals :right. Save and refresh. That looks good. But we still have no underlying function because we are missing the implementation of the method change address. Switching back to the ABAP editor, this time in our sys customer class, we see that the file already has other methods, including one called change visits. We can copy the method change visits and rename it change address corresponding to the new push button and save. That was the declaration of the method. Further down in the file, we now implement the method, beginning and ending with the statements method change address and end method, respectively. And in the middle, we call an object of the external class S10 Customer from the ABAP class library SE24. When we call the method address change, we also have to pass the parameter customer number, KUNNR. Upon going back into the original view, the customer data must be read in anew so that the changes are displayed. That should be all we need to execute the user dialog for the address change. This example shows that calling methods containing user dialogs is identical to normal method calls. A new object is created from the corresponding SE24 class, and the desired method is called with the necessary parameters. The new object is responsible for the dialogue with the user for a limited time, and after returning to the app, the data are read from the database again. Let's save, activate our ABAP program, and test after restarting the app with the ABAP modifications. Pressing the Change Customer Address button does, in fact, take us into the Change Address dialog, which is now in control. To test the dialog, let's change the house number to 16 and save. The confirmation message that pops up also originates from the address change object, as would any error messages. Going back to the customer view in the app, we see that the house number has in fact been changed. Furthermore, the new address is also used by Google Maps, even though it is not displayed directly on the map itself. Calling ABAP objects with dialogues is easy to implement and at the same time a very powerful means to build complex web applications with reusable building blocks. The network of application objects active during runtime is made up of objects that work closely together as well as numerous independent and reusable objects with dialogues. In the last few minutes of the demonstration video, let's turn our attention to something quick and easy. In the Settings tab, we have the options to change the color scheme. The standard is Fiori, but we can also choose Fall or Winter. For demonstration purposes, let's save the color scheme Fall. Go to the customer view in the app, which now has the new fall colors that are also used for the Change Customer Address dialog. This gives the whole application a unified look. Let's go back to Settings and switch the color scheme back to the default, namely Fiori. That brings us to the end of today's video. Detailed documentation and additional videos on several exciting new topics are currently in the making. The S10 Framework will be available to the general public as of the beginning of March 2022. Pilot testing begins in January 2022. The S10 Framework is free of charge for up to 10 users. Purchase prices above 10 users are comparable to those of the GUI XT Input Assistant. If you are interested in trying out the demo application on your smartphone, tablet, or PC, just follow the link below the video. We thank you for your interest and look forward to any feedback, questions, or suggestions you might have.